Hello and welcome back to IME 315. Last week's assignments were to get you more familiar with the various accounting statements the companies need to put together. The reason for this was that this class, Financial Engineering, is about justifying projects. And in order to justify projects, we need to get familiar with the various items that make up an income statement. Sales speak for themselves primarily. They're pretty easy to understand. But we're going to talk about this week, and it's going to be in 3 lessons. They're going to be brought up individually, is the cost of goods sold item. So if we want to justify a project, we need to understand what kind of revenues the project is to generate, and we need to understand the costs of the project, and we need to understand all costs. So today we're going to talk about materials in this lesson. And so if we think about an individual product, there are 3 components that make up a product cost. And what we're going to do is understand what these components are, how to determine the material cost of a single product, and then how to determine the material cost of an assembly. So that difference from a single product to putting together multiple components into a product. So the components that make up the product cost, there's 3 of them. So we have the selling price, and that's the first in financial engineering. That's the first thing when we want to justify a product. We have to understand the selling price. And then we have the 3 components of the cost. There's overhead, materials, and direct labor. And the difference between the 2 is profit. And so if we look at our unit selling price and our unit cost, we have a unit profit. And then we just multiply that by the number of units, and that gives us our profit. So let's look at direct labor. How do we determine direct labor? Well, we do it from time studies, work sampling, and understanding every step of the manufacturing process. And we get this from other classes in IME. I believe it's 223 is the first introduction to it. And then we need to understand how much an employee costs, his direct rate. We need to allow for vacation, taxes, and benefits. And that gives us a time. Our direct labor is the time for each unit times what an employee gets paid per hour, and it's a fully allocated per hour. And then when we look at the material cost of a component, we need to know what the quantity is, and we need to factor in scrap and loss rates, and we need to factor in quantity discounts, recycling returns. And material cost is the cost of the raw material per unit times the number of units. And then finally, overhead. And what is overhead? Overhead it's not directly related to the cost of production, but you need it. We need to have a building. We need to have electricity and air conditioning. We need to have a supervisor. We need to have consumables. So that's overhead. So those are the 3 components of material cost: direct labor, materials, and overhead. So the fully allocated cost is going to be the overhead per unit plus the material per unit and the direct labor per unit, and that gives us the fully allocated cost per unit. So let's look at the material cost of a single product. So we're going to work on item number 2, the material cost. We'll get to the direct labor and the overhead in later presentations this week. So here's our basic formula. It's the material cost per unit, M, is the cost of the raw material per batch, less the recycled value per batch, and that quantity divided by the number of good units in a batch. Okay, now, when we're looking at this, don't just rely on this formula by itself. You need to apply some common sense to it. So if, for example, when calculating N, if we know that something is 72 inches long and it needs to be machined into 8-inch pieces, that would tell you that you could have 9 pieces. However, if you have a loss in the machining, then your number of units can only be 8. So we need to apply a little bit of common sense when we're looking at these numbers. Let me take you through an example. So let's say we have a 6-foot length of cold rolled steel. And the density of the steel is 5.518 pounds per foot. The cost of the steel is 80 cents a pound. And so we have a 72-inch piece of bar stock. We put it in a lathe, let's say. 1 inch is lost to the collet. So this is going to be, you're not going to get this. Every piece you cut, you lose 1/8 of an inch. And you're going to make a widget, and each widget weighs, not weighs, is 1 1/8 inches long. So step 1, let's assume that there's no recycle value and every part is good. So the cost of a batch is 6 feet times 5.518 pounds per foot times 80 cents per foot, per pound. That should be per pound. I'm sorry, 80 cents per pound. So $26.49 per batch. We're saying there's no recycle value, and we're going to assume that every part is good. Okay, so let's look at what N is. So for every unit, we're going to lose the 1 inch loss to the collet, and then each piece is going to take up 1.5 inches because we have the finished product size and then the loss of material of 1/8 of an inch. So we end up with 56.8 widgets per length of bar stock, which is 72 inches minus 1 divided by 1.5. We can't have 0.8 of a widget, so we end up with 56 widgets. And so we go to our formula, M equals R minus V over N. V is 0. We have no recycle value. We're spending $26.48. We have 56 units. They're all good with 56 widgets. Costs us 47 cents a piece. So this is the simplest calculation right here. Everything is good and there's no recycle value. Okay, let's change this a little bit. Let's assume we don't have any recycle value, so we're going to leave V as 0, but we have a 5% scrap rate. Now, that means we're going to make 56 widgets and 95% of them are going to be good. So we're going to get 53.2 units, 53.2 widgets on average per length of steel. So now N is 53.2. You may be asking, why am I not rounding this down to 53? Because we're having a 5% scrap rate. We don't know if we're going to lose 1% or 7% on a bar of steel. So this is an average number. It's not on 1 bar of steel. If we were going to only use 1 bar of steel and we had a 5% scrap rate, then we would use 53. But if we're going to use 1,000 6-foot bars of steel, we use the decimal, the larger decimal. So if you have a 5% scrap rate, our cost goes from 47.3 cents per unit to 49.8 cents per unit. Now, let's take the same assumption. Everything is the same, but we have a 5% scrap rate and the metal can be recycled at 10 cents a pound. So now what we need to do is we need to calculate V. So a good rod, or a single rod, is 6 feet times 5.5 pounds per foot, or 33.1 pounds. Now, the number of good widgets we're going to get in this 6-foot length of steel is 53.2. So we have 53.2 widgets, and this is a proxy, this is a conversion from inches to feet. So the 53.2 widgets, which are good, weigh 27.5 pounds. So you'll need to double check this calculation here to recognize 53.2, and this is the density gives us 27.5 pounds. That's the good material in this bar. So the bar weighs 33.1 pounds. We're going to have 27.5 pounds of good material. That means our lost material is 5.587 pounds. We get 10 cents a pound. We get 55.87 back. So M equals R minus V over N. R is $26.49. V is 55.87 cents. We got 53.2 good units. So now our cost per unit is 48.73 cents per unit. So this is a single unit. Now let's say we have multiple components to a unit. So multiple products. So let's say what we want to do is we want to make a gadget, not a widget. And in order to make a gadget, we need 3 widgets, we need 1 spring, and we need 4 fasteners. So we need 3 components to a gadget. And we've already gone through this calculation and determined that a widget is $2 and a penny, a spring is $3, and a fastener is 50 cents. So step 1, we want to find out what the material cost per gadget is. Step 1, we're going to assume no recycle value and every part is good. So each widget costs $2 and a penny. There's $3, three of them per gadget, $6.03. Each spring costs $3. There's 1 per gadget. That costs $3. Each fastener costs 50 cents. There's 4 per gadget, $2. You add these 3 components up, you get $11.03 per unit. That's if there's no recycle value and every part is good. Now, let's look at change this a little bit. The parts are assembled into a finished product. 1 in every 50 widgets are bad and must be scrapped. 1 in 25 springs are bad and are scrapped. The bad parts can be identified before assembly, and the fasteners are never bad. That's important. The bad parts can be identified before assembly, because that means that you're not losing, you don't need to take them apart. What is the material cost per gadget unit? So the assumptions, 1 in 50 widgets are bad, 1 in 25 springs are bad. We're going to assume no recycle value. So now the cost of a widget, the 3 widgets, we have a 2% scrap rate of widgets, we've got a 4% scrap rate of springs, no scrap rate of fasteners. So we take our $6.03, which is the 3 widgets, 0.98 is the number that are good. It's $6.15. Our spring, we divide by 0.96 because 4% of them are bad, $3.12.5, and then fasteners are always good. Our cost has increased from $11.03 a unit to $11.28 a unit. So recognize we're doing the components individually and adding them up. Okay, let's go to part 3 now. Let's just say that 1 in every widgets are bad and must be scrapped. One in every 50 widgets are bad and must be scrapped. Same scrap rate. We have a 4% scrap rate of springs. And only the widgets can be recycled for $10 per 100. The fasteners are never bad. So V is always going to be 0 for the spring, but we can recycle the widgets at $10 per 100. So the value for the widgets is 10 cents per unit. If we have a 100 unit batch, a 1 unit batch will give us 0.2 of a cent. So now we can calculate our recycle value per unit. Remember, this 0.2 of a cent is per unit. We have 3 units, so on average we're going to get 0.6 of a cent. So the price of our widgets has decreased from $6.15, $6.15.3 to $6.14.7. It's just a little over half a penny. And so our cost per unit is $11.27 versus $11.20 when we include the value of the scrap, the recycling of the widgets. So the takeaway from this lesson is that when we compute the direct material cost, we need to include the cost of the material, the recycled value of the material, and the number of good products per batch, or good pieces per batch, to calculate the individual cost of a unit. We can do that with a single product or multiple products to a part. Multiple products to a part, we do the single parts individually and add them up. There's going to be 2 more parts to this lesson, talking about direct labor and overhead costs. And then I'm also going to be bringing in other types of costs. Because for financial engineering, we need to understand our costs. As industrial engineers, costs are a very big deal. On this startup company that I'm working with, I have single line items for my revenues. I have multiple line items where I'm estimating costs. I might have 3 different sources of revenue. I probably have 25 different types of costs. The costs, revenues are much easier to calculate. Costs, on the other hand, we need to go through lots and lots of details. Thank you. I'll be bringing up part 2 in a little bit.